Today is Thursday, August the 20th. In pre-calculus today, we looked at extrema, increasing and decreasing, and average rate of changes. So I will go and share my screen, and we'll look at the whiteboard to see some of the things we did today. Now, we'll look here at the function which we're all familiar with, which is the the x squared function. So we can talk about the things we're looking at here, because the x squared function here is the only function that we can find a max or min algebraically. Okay, so if we look at y equals x squared here, remember y equals x squared is a parabola. It comes down like this. It goes through the origin and it goes back up like this. Okay, now, so if we look at extrema, we'll talk about extrema here. This is max and min points. All right. So in the case of a parabola here, this point here at the origin, right here, which is the vertex of the parabola, this would be an absolute minimum point. We do ABS and min. Now, it's an absolute minimum point because there's no point, no other range value or no other y value in the whole graph that is lower than that. Now, the parabola here has no absolute maximum point because it goes forever in the vertical direction here off to positive infinity in both the second quadrant here and the first quadrant. So for extremely here, the only thing we're looking at is an absolute minimum. Now, if I have a function very quickly here, if I have a third degree function over here, if I draw it, say I come up like this, I come like this and go like that. So this is my y-axis. And this is my x-axis over here. Say this point right here would be a local max. And this point right here would be a local min, because this point is the smallest point in its neighborhood, and this point is the largest point in its neighborhood. So this function right here would have a local min, a local max, but once again, no absolute max because it goes off to infinity in the first quadrant, and no absolute min because it goes off to infinity or to minus infinity in the third quadrant, okay? Now, if we look over here, the next thing we talk about is increasing and decreasing, INCR, and decreasing. Now, so when we're looking at increasing and decreasing, we're talking about what happens when is the x values. Now, we're not talking y values, we're talking x values that tell us when the function is going down as it goes from left to right. So if I'm looking here at decreasing, I would come here, decreasing is from minus infinity, minus INF to 0. And then my increasing here, my increasing would go from 0 to positive infinity, because from here up to here, the function is increasing. Okay. Now, let's say we have here, this is the y equals x squared function. y equals x. Remember, if I put this now stop button, that's the same thing as exponent. So y equals x squared. So we have a point here, let's say, which is this point here would be, say, 3 and 9. That's 3 and 9, which 3 squared is 9. Now, okay. Now, if I come over here, I have a point which is -1 and 1. Now, the last thing we did today was to find the average rate of change. And the average rate of change is just, if you look at it's going to be the y2 minus y1 divided by x2 minus x1. And it's basically, it's just a slope, but what you're doing is you're finding the slope of the secant line that connects these 2 points across here. So it's not a slope of the function, but it's the average value of the function. So between these 2 points right here, the average value equals that slope. So I will come down here, if I look at those 2 points, so I can put the average value. So we'll come down here and put the average value equals average rate of change equals, okay, so y2 is going to be 9 minus y1, which is 1. So you see the 9 here and the 1 here, and we divide that by divided by x2, which is 3, minus x1, which is 1. So we get an answer of 8/2, which is 4. So the average rate of change between this point here, when x is -1 to x is 3, is 4. Now what that says is every time I go across, now I got to go back because I made a mistake here, right? See, look, let's go back. Because what do I do here? See, I got to do 3 minus a -1, okay? That makes a difference because now instead of having 8/2, I have 8 divided by 4, which is 2. Now that makes sense because so every time x changes by 1, y changes by 2. So I go from -1 to 0, so this would be 3. I would go over 1 more, so that would be 5. I would go over 1 more, so that would be 7. And I would go over 1 more, and that would be 9, okay? So now we'll stop sharing here. If you have questions as you're looking at your homework, send me an email and let me know what your question is, and I will respond accordingly. Now notice once again, tomorrow we're looking at the mid-chapter quiz for chapter 1. You're doing problems 1 through 9 and 11 through 15. So if you would send those to me either in OneNote or in an email with an attachment, then I will get back to you with the grade, okay? So I will see you tomorrow, and have a good day.